press the bell icon on the YouTube app and never miss another update.
Hello dear students, now let me continue center of mass part number 6. So in this session also let me cover some more problems and concepts related to center of mass. Okay, so let us start the problems now from center of mass. So find center of mass of the system as shown in figure. So I am going to draw the diagram. Let us find the center of mass of the system as shown in figure. See the given diagram like this. I think you know this diagram in laws of motion. M1 M2. Let us suppose M1 is greater than M2. See the given two blocks of masses M1 M2, they connected to the wire and that wire is passing over a frictionless pulley. So this arrangement you know it is called as Atwood's submission. So it is there in laws of motion chapter, Atwood's submission. Okay, now our target is to find acceleration of center of mass of the system. Okay, this is acceleration of center of mass of the system as shown in figure. So the given this diagram, our target is to find acceleration of center of mass of this system. Okay, just recall basic formula of acceleration of the system. Acceleration is different from acceleration of center of mass. So acceleration of the system from laws of motion you remember. So acceleration when two blocks are arranged like this, acceleration you know, so that is m2 minus m1 or difference between the masses m1 minus m2 by m1 plus m2 into g. I think you remember this formula. Acceleration of the system formula is difference between the masses by sum of the masses into gravity. Okay, acceleration due to gravity. So this is the acceleration of system, but not acceleration of center of mass. Our target is to find acceleration of center of mass of given system. Okay, so this is already done in laws of motion. So I am using direct formula. A is equals to difference between the masses. If m1 is greater, then m1 minus m2. If m2 is greater, m2 minus m1. So m1 minus m2 by m1 plus m2 into g. Okay, if this mass is more, it will move down with an acceleration of something a1 is equals to a, and this is moves upward with an acceleration of a2 is equals to a. Okay, so I written a1 is equals to a, a2 is equal to a from constraint relation. Okay, if one is down, other one is up. If one is positive, other one is negative. So let us write if a1 is a, a2 is minus a, opposite. Okay, any one you can take it as a negative. Okay, if a1 is positive a, a2 is negative you can take. Now acceleration of center of mass we can write as ACM. We can write as m1 a1 plus m2 a2 by m1 plus m2. See, this is the acceleration of center of mass. This is acceleration of center of mass. Already we calculated in the last session. So a1 you can take as a positive and a2 is negative because they are opposite, equal and opposite. So acceleration of center of mass we can write it as m1 a and a2 I am taking minus a, so m2 a by m1 plus m2. Now we can take a common. Acceleration of center of mass is m1 minus m2 by m1 plus m2 into small a. What is small a? This a is acceleration of system. This is acceleration of center of mass of the system. Okay. Substitute a value. Then acceleration of center of mass of the system m1 minus m2 by m1 plus m2 into a. What is a? A from this equation, from equation 1. So from 1 we can write m1 minus m2 by m1 plus m2 into g. So this is written from equation number 1. Okay. So I think this is not visible. Let me write. So ACM we can write it as m1 minus m2 by m1 plus m2 into a. This a you write m1 minus m2 by m1 plus m2, m1 minus m2 by m1 plus m2 into g. Now acceleration of center of mass is m1 minus m2 whole square, m1 minus m2 whole square, or you can write this as m1 plus m2. So m1 minus m2 by m1 plus m2 whole square into g. So acceleration of center of mass is m1 minus m2 by m1 plus m2 whole square into g. See, this is the acceleration of center of mass of given system. Okay, acceleration of center of mass of the system. For suppose in a problem, if this block is moved down by something 4 meter distance, or in 2 seconds. Okay, in 2 seconds if it is traveled someplace, in something time is given, in 2 seconds if it is traveled some distance, then that distance also we can find by using kinematics. See, after 2 seconds where is the block 1, that also we can find if we know acceleration of center of mass. See, okay, if they given time, means after 2 seconds where is the block m1, at what distance it is going to be covered, if they ask, then you can use distance travelled by the block m1, which is equivalent to s is equals to ut plus half at square. Anyhow system starts from rest, so u0, so half at square, half a nothing but acceleration of center of mass t square. Then s is equals to half acceleration of center of mass is m1 minus m2 by m1 plus m2 whole square. So s is equals to, if they ask the distance after 2 seconds, then use half at square, half acm into t square. So s is equals to half acm, nothing but m1 minus m2 by m1 plus m2 square into t square. Okay. So this is the distance travelled after t seconds. Okay, if they ask, you find this one. Now I got acceleration of center of mass of given activity machine is m1 minus m2 by m1 plus m2 whole square into g. Take this. We will do one more good level of question related to this. Okay, one more some JEE level question I am going to solve. Okay. So next answer the same question. Find acceleration of center of mass of the system as shown in figure. So I am going to do the diagram. Find acceleration of center of mass of the system as shown in figure. This is given 30 degrees, this is 60 degrees, they given identical masses. See, this is the diagram. So I am going to calculate acceleration of center of mass of this system. Acceleration of system is different. Again, I am going to find acceleration of center of mass of the system. Okay, acceleration of the system and tension in the string you already calculated in laws of motion. I hope that everyone remembered. So, acceleration of the system, tension in the string already done in laws of motion. But here, our target is to find out acceleration of center of mass of given system. Yeah. See, here there are two blocks. This block makes an angle 30 degrees. This makes an angle 60 degrees. Okay. So here both are identical. Let us suppose if it moves down with an acceleration a1 is equals to a, then this will move in this direction with the same acceleration. Okay, with the same acceleration a. Okay, and you know how to find out this a. A is acceleration of the system. So I think remember a is equivalent to m2. Some will remember if this is alpha, this is beta. Recall laws of motion concept. If this one is alpha, this one is beta. m2 sin beta minus m1 sin beta by difference between the masses with respect to some angles. m2 sin beta minus m1 sin beta by m1 plus m2 into g. Okay. So m2 sin beta. So let us take this is m2. Okay, m2 is m. m1 is m. Okay, a1 is a, a2 is opposite minus. Then acceleration of the system is m2 minus m1. m2 sin beta sin 30 minus m1 sin 60. m1 is m, m2 also m. By m1 plus m2, m plus m plus m into g. So this is only acceleration of system I am finding now. M sin 30 minus m sin 60 by 2m. So m sin 30, m sin 30 is m by 2. M you can take outside 1 by 2. This is m sin 60 root 3 by 2. Okay, root 3 by 2. And see, so this is moving down. Better you can write like this because the highest mass, difference between the masses, see the gradients. Otherwise you may get negative. So m1 minus, okay, m earlier formula a is equals to m1 minus m2 by m1 plus m2 into g. Now I am doing the same thing. A is equals to m1 sin 60, m1 sin 60. Okay, this is from laws of motion, so no need to explain here. m2 sin 30 by m1 plus m into g. This is the acceleration of system. So a is equals to m1 is nothing but m sin 60 is root 3 by 2. This is also m 1 by 2 2m into G. So if you take m common, so m gets cancelled and 2 common, then you will get root 3 minus 1 by this 2 comes to the down 4 into G. See, this is acceleration of the given system, but our target is to find out acceleration of center of mass of the system. Okay, this is already done in the laws of motion chapter. Okay, up to here already you know in laws of motion. So I am using the laws of motion formula, free body diagram concept. Okay, I got A. So keep this A value. What is this A? A is acceleration of the system. Take up to here now. I will continue how to find the acceleration of center of mass of the system. Okay, take up to here. So A is equals to, I got root 3 minus 1 by 4 into G. Let's write this A value here now. So keep this A value in mind, because I am going to find out acceleration of center of mass. Okay, so acceleration of center of mass. Let me rub this. Yeah. Still it is not yet completed. Target is to find out acceleration of center of mass. So how to get acceleration of center of mass? Acceleration of center of mass nothing but ACM is equivalent to m1 a1, okay, a1 bar, m2 a2 bar by m1 plus m2, because a1 a2 are vector quantities. Okay, here resolve this a1 into two components, a2 into two components. Okay, follow the resolution method. Divide a1 into two components, a2 also into two components. Observe which side the body is moving, which side the block is moving. Okay, so imagine the free body diagram for this, or otherwise resolve this a1 into two components. Acceleration of m1, let me draw a diagram here. See, I am going to draw acceleration of m1. This is m1, which is equal to m, and it is moving down with a1 is equals to a, and see it is down, and see the angle. If this is 60, see, if this is 60, no doubt this value also 60. So this is 60. Follow the geometry. A1 60. So resolve this A1 into two components. One is left side is A cos 60 and downside is A sin 60. So I divided A1 into two components. Is it visible? A1 into two components. A1 cos 60, A1 sin 60. Coming to the A2. A2 is in this direction. It is making some 30 degrees with respect to the horizontal. So let me draw M2. M2 anyhow this is equivalent to M. So draw the free body diagram. Now see how much this angle? 30 degrees. So this is A2 is equals to A, and this is what? A cos 30, and this is A sin 30. So A1 A2 are resolved into two components. For block 1, A1 cos 60, nothing but A cos 60, A1 A2 are equal and opposite. A cos 60, A sin 60. Coming to the block 2, of course both are identical. So A cos 30, A sin 30. Now how to get A1? A1 nothing but A1 nothing but A cos 60 minus I क्या? Because left side A cos 60 minus I क्या? A sin 60 minus J क्या? A cos 60 minus I क्या? A sin 60 minus J क्या? Coming to the A2. A cos 30 minus I cap left side. Okay, along negative x axis. So see, this is negative x axis. A cos 30 minus I cap A sin 30 plus j cap. So let me write here. ACM, acceleration of center of mass. M1, anyhow M. How to get A1? A1, write A1 bar into two components in vector form. So A1 resolved into two components. One is left nothing but minus I cap. One is down nothing but minus j cap. A cos 60 minus I cap. A cos 60 minus I cap. A cos 60. So let me write it 1 by 2 minus I cap. Minus I cap. One more. A sin 60 minus j cap. A sin 60 minus j cap plus A sin 60 root 3 by 2 minus j cap. So this is A1 bar. A cos 60 minus I cap. A sin 60 minus j cap. A1 bar completed. Coming to the A2. M2 is M A2. A2 also resolved into two components. A cos 30 minus I cap. A cos 30. A cos 30 means root 3 by 2. Left side means minus I cap. And upwards is nothing but plus j. A sin 30 plus j cap. Yeah. Observe carefully, write correct notation. Divided by total mass, nothing but what? M plus M. Take A common. If possible, we take minus also common if anywhere is there. So let me write ACM bar. M, anyhow you can cancel it. So let me write M outside, A outside. This is minus I cap by 2. Okay, minus I cap by 2 minus root 3 j cap by 2. M we already taken out, and minus root 3 by 2 I cap, just multiply it. A already taken out, so plus j cap by 2 divided by 2m. Okay, so ACM bar, acceleration of center of mass, is A into I cap by 2 root 3 j cap by 2 root 3 I cap by 2 j cap by 2. Better you can go for the magnitude. Root of whole. So root of a square is A, 2 is 2 square is 2, and this becomes root, this is what? 1 by 4 I square by 4, this is 3 by 4, 3 by 4, I am taking the magnitude 1 by 4, 1 by 4, 1 by 4, 3 by 4, 3 by 4, 8 by 4, this will get A by 2 root 2. This is magnitude of acceleration of center of mass. But we are getting answer in terms of small a. What is small a? What is a? A is acceleration of the system that calculated from laws of motion chapter. Means just now I calculated. What we got acceleration of the system? Just recall the value. Just now I completed root 3 minus 1 by 4 into g. I think this is 1. Root 3 minus 1 into 4 by g. Okay. Now this can be plus substitute a value. This is a by root 2. So what is a? Root 3 minus 1, root 2 already there. 4 root 2 into g is our answer. So acceleration of center of mass. So acceleration of center of mass, magnitude of center of mass is root 3 minus 1, 4 root 2 into g. So this is the answer for given question. See how lengthy. Slowly I am extending the level of questions. Observe carefully now. I got finally acceleration of center of mass of the system is root 3 minus 1 by 4 root 2 into g. Okay. So practice it is twice. This already done from laws of motion. So this is acceleration of the system and I calculated acceleration of center of mass of the system. Both are different. Acceleration of the system is different from acceleration of center of mass of the system. Do correct calculations. Okay, completed. So practice twice if you feel any inconvenience. Okay, easy because I am following easiest methods. Okay, here resolution is important. How I divide M1 into two components means acceleration of this block into two components, acceleration of this block into two components. Okay. Now let me solve some easy problems. Otherwise, let me continue. Methods to locate center of mass. So next concept purely for entrances. Methods to locate center of mass means how to find center of mass in different cases. See, there are 4 methods to locate the center of mass. One is purely for entrances, keep in mind. So purely for all type of entrances, JEE and NEET. See, there is a one we can call it as a method of symmetry. Method of symmetry, and another one method of decomposition, division. Okay, decomposition. Third, method of integration. So integration is little trouble for you especially. Okay, I will write, means I will show you every derivation in case of integration. And one more is there, we can call it as Pappus theorem. Okay, earlier we used that theorem. Right now by using integration method only you will get the answers. Okay, so okay, let me write that also. Method of Pappus theorem or Pappus theorem. Okay, keep in mind there are 4 methods to locate center of mass. Now first one is method of symmetry, second one method of decomposition, third one method of integration. Okay, that is possible for mass distributed objects, continuously mass distributed objects. Okay, and other one is Pappus theorem. Okay, so Pappus theorem is not required. Based on the situation, I am going to cover Pappus theorem also. So these are the 4 methods to locate center of mass. Now let me start method of symmetry. Okay. Now let me start first method to locate the center of mass or to find the shift in center of mass in different cases. See, they given like this. They given two circular discs. Okay, so two. Okay, keep in mind these are concepts. Okay, two circular discs. Circular discs of radii R1, R2. They given two circular discs of radius is mentioned R1, R2. They are in contact with each other. Okay, R1, R2 are in contact. In contact with each other. Okay, so let us see how they are. See, this is first disc and this is another disc. Okay, this radius R1 and this one is R2. Okay, both are circular discs. Now our target is to find out center of mass of this system from the first disc. Okay, if one disc is there, center of mass is here. C1 is the center of mass of first disc. C2 is the center of mass of second disc. If they are in contact with each other, then there will be a shift in center of mass. Center of mass will change. Okay, if they are individual objects, center of mass of this one is at center, at centroid. Center of mass of second disc also at centroid. If they placed in contact with each other, center of mass will change. I think you know in which side the center of mass will shift. Center of mass is always nearer to the heavier mass. Okay, if M1 is the mass of the first disc, M2 is the mass of the second disc, no doubt center of mass is nearer to heavier mass. So let us take here. This is the center of mass. Center of mass. Center of mass shifted to the heavier mass. Now the distance between these two centers, let us take it as D. Distance between the two centers, I am taking it as D. Here, target is to find out distance of center of mass from first disc. Okay, let me find distance of center of mass. Distance of center of mass from M1 is, so you know how to find out distance of center of mass from first one. Okay, if two masses are separated by some distance d, then we know how to write distance of center of mass from M1 and distance of center of mass from M2. So this can be written as XCM. We can write as M2 d by M1 plus M2. Distance of center of mass from M1 is opposite mass into distance gap between the centers divided by total mass. Let us say how to change these masses. Anyhow, radius is given. The given T is the thickness of each disc. T is the thickness of the disc. Okay. Now we can change that masses into radius term. Anyhow, we know mass we can write as volume into density. Mass we can write it as volume into density. So we can write mass as volume nothing but area into thickness into density. Okay, area into thickness of the disc is nothing but a volume. And this area we can write as pi r square into T. See, anyhow, for a disc, pi constant, thickness constant, same thickness and same material, density constant, same thickness, T constant, pi anyhow constant, same density, density also constant. So, mass of the disc varies with respect to only square of the radius. Mass of the disc, each disc is varies with respect to square of the radius. So in place of m2, anyhow I am taking proportionalities. Otherwise you can write this one pi r2 t rho. Anyhow all the pi r t rho will be cancelled out at the end. m2, anyhow m2 proportional to what? Directly write r2 square. m2 proportional to r2 square. Some constants are there. Constants are there in numerator and same constants are there in denominator. Those constants will cancel with each other. So no need to worry about the constants. Into d. What is d? D is the distance between two centers. D is the distance between two centers of two discs. This is R2. From here to here is R1. This is R1 and this is R2. R1 radius, R2 radius. D is equivalent to R1 plus R2. M1, nothing but we can write R1 square. M2, R2 square. Now this is the distance of center of mass from M1 disk. If they ask you to write the distance of center of mass from M2, then similarly, distance of center of mass from M2, how we can write XCM is M2 nothing but this is M1D by M1 plus M2. What is M1? M1 nothing but R1 square, D nothing but R1 plus R2. Again M1 nothing but R1 square, D nothing but M2 nothing but R2 square. So I written distance of center of mass is from M1 disk and distance of center of mass from M2 disk. Okay. So I started the first concept, method of symmetry. Okay. So two circular discs of radii R1 R2 are in contact with each other. Then the distance of center of mass from first disk formula R2 square into R1 plus R2 by R1 square plus R2 square. And similarly distance of center of mass from M2. Okay. I changed that M into radius terms. Otherwise wherever M is there you write if it is M1 pi R1 square t rho. T rho constant, pi constant. Only R is variable. So that's why I written in place of M as a R. Okay. Method of symmetry. Take this. So this is for circular disc. If they given the sphere, tell me. If they given the sphere, for sphere mass of the sphere proportionals to volume into density. In volume we can use 4 by 3 pi r cube. So in volume of the sphere nothing but 4 by 3 pi r cube. So mass proportionals to cube of radius. Mass proportionals to cube of radius. So in place of square just you use cube if they given sphere. Okay, if two spheres, one sphere of radius r1, another sphere of radius r2, if they are in contact with each other, then distance of center of mass from first sphere is r2 cube into d is same r1 plus r2 by r1 cube plus r2 cube. Similarly, distance of center of mass from second sphere, we can write r1 cube. In place of square, cube will come because mass proportionals to cube of radius. Okay. So if they given for a spheres, right here for spheres mass varies with cube of radius. So distance of center of mass from first sphere is r2 cube r1 plus r2 by r1 cube r2 cube. This is distance of center of mass from M1 sphere. Okay, this is is one sphere and this is another sphere. M1 sphere and M2 sphere. Same diagrams. So on both diagrams are same. This kind of sphere diagrams are almost same on both diagrams. Okay. So spheres, you write cube of radius. Now let me continue one more. Okay. See, they given like this. Two uniform rods. Two uniform rods of lengths L1, L2 and thickness is same. Okay. Two uniform rods of lengths L1, L2. They are joined to form a T-shape objects. T-shape as shown. So the given like this. See, this is one rod. This is another rod. These are basic concepts, very basic level of concepts. Okay. Only that integration concepts are important for JEE level, remaining all are important for NEET and other exams. Okay. Here this is L1 and this one is L2. Let us take M1 is the mass and M2 is the mass. Center of mass of M1 rod is at center. Let us take it as C1. And center of mass of M2 is also at center. Let us take it as C2. C1, C2 are the center of masses of those two uniform rods. Okay, uniform rods with uniform density. If it is a non-uniform density, we have to go for integration method. Right now, uniform rod with uniform density, uniform thickness. So, here let me find distance of center of mass from first rod. Okay, once we know distance of center of mass from first rod, we can get the distance of center of mass from second rod also. Let me get distance of center of mass from C1, from first rod. Okay, so distance of center of mass from M1 is, we can get, let us use, I am using HCM. So opposite mass M2D by M1 plus M2. What is D? D is the distance between two centers. D is distance between two center of masses. And see how this M is going to vary. Mass we can write as, for uniform objects, mass anyhow we can write. So mass varies with respect to, so length. So L rho. So what is L rho? Here this rho is the linear density of the rod. Rho is the linear density. Linear density nothing but mass per unit length. So this is mass and length. This is mass per length. So length cancel, mass and mass are equal. So what is rho? Rho is the mass per unit length here. Okay, don't think it is density. Mass per unit. It is a linear density. Okay, rho is the linear density. So mass proportional to length density, linear density is constant. See, this is linear mass. Linear density, otherwise linear mass. Okay, so mass varies with respect to L rho. So mass proportional to L. Now let's see distance of center of mass from M1. M2, what is M2? L2. D, what is D? D is the distance between these two centers. Distance between the two centers is what? From here to here is L2. This is L2. And this is half of the L2. Nothing but L2 by 2. half of this L2 by 2. What is D? D is equivalent to L2 by 2 by M1 proportional to L1, M2 proportional to L2. So distance of center of mass from the first rod, we get it as L2 square by 2 into L1 plus L2. L2 square by 2 into L1 plus L2. So this is the distance of center of mass from L1. If the rods are having same length, if for suppose if L1 is equals to L2 is equal to L, then distance of center of mass from first rod is L square by 2 into 2L. See, L2 square, L square by 2 into L plus L. L plus L is 2L. 2 into 2L, 4L. L cancel, L by 4. If they are having same length, if they join to form as a T shape, then distance of center of mass from the C1 end is L by 4. If they are having same length. Okay. So keep this concept in mind. Let us try one more concept. Yeah, completed. See, every time I am following M2D, opposite mass into distance by total mass. Clear up? Yeah. See, they given two hollow cylinders, okay, whose radius is R1 and R2. Lengths are given L1 L2. They are joined end to end. Now our target is to find out center of mass of that system from one end of the, means from center of the first cylinder or from center of the second cylinder. See, let me write here two hollow cylinders of radii R1 R2, lengths L1 L2 are joined as shown, shown in figure. Let us see how they are going to join. Okay. See, this is one cylinder. And one more cylinder is joined like this. This radius given R1, this radius is R2, length is L1, length is L2. And center of mass of this first cylinder, let us take this is M1 and this is M2 mass. Center of mass of the first cylinder is C1 and second cylinder is C2. The distance between these two is D. D is the distance between two center of masses of the objects. Okay. Now here see, this is heavier object, so center of mass is nearer to this and this is the position of center of mass. Now let me find HCM, means I am finding distance of center of mass from center of first cylinder, means opposite mass into distance between two centers by total mass. Again, what is the formula for HCM? XCM formula very clear again. So M2D by M1 plus M2. But convert that mass into some other terms. Okay, mass into some other terms. Here they given two hollow cylinders of radii R1 R2, lengths are given L1 L2, they are joined end to end. Okay, if they join end to end, center of mass of the system changes. Okay, center of mass will shift. Now, initial center of mass are C1, C2. Center of mass of the system is here because it is nearer to the heavier mass. Okay. See, what is this D? This is L1. This is L1 by 2. L1 by 2. And this is L2. This is L2 by 2. Half of this. L2 by 2. L1 by 2. Then what is D? D is very clear. L1 by 2 plus L2 by 2. So, L1 plus L2 divided by 2. So, D value is clear. L1 plus L2 by 2. Let us get the mass. So, how the mass is going to vary? Mass nothing but volume into density. Density means uniform density. Nothing is given means density remains constant. Okay, uniform density. Volume. We can write area into length. So, we can write area into length and density. So, area pi r square. Okay, circle. Okay, circle pi r square L rho. And observe here, pi remains constant, rho remains constant. What are the variables? R ideal. So, mass is varying with respect to the radius and with respect to the length. So, mass here varies with respect to R and L. Mass is changing with respect to the radius and with respect to the length of the cylinder. Now, wherever the mass is there you write like this. XCM we can write XCM M2. What is M2? M2 nothing but R2 square L2. Because M varies with respect to radius and with respect to the length of the cylinder. Some constant terms are there that will come in the numerator and denominator cancelled out. So I don't want right now. R2 square L2 D. What is D? L1 plus L2 by 2 divided by M1. What is M1? R1 square L1. What is M2? R2 square L2. See, this is the distance of center of mass from the first cylinder. If they ask to write from second cylinder, this will be reverse. R1 square L1 remaining is same, L1 plus L2 by 2 by R1 square L1 plus R2 square L2. Okay. So this is the distance of center of mass from first cylinder. Okay. Take this up to now.